Alright guys, Chapter 11, we're really not going to spend much time on it. Chapter 11 is over recursion. What is recursion? Recursion is when a method calls itself. So I do want you to look at the PowerPoint, and read the chapter, at least skip through the chapter, definitely look at the PowerPoint. However, I'm not going to even hit the chapter. I'm just going to give you a demonstration in code. Right. So what does it mean when you say that a function calls itself? Let's create a new one, element. I think we're on lecture O. Guess I could validate that before we go on. Week 8, lecture O. Nope, we're on P, lecture P. Glad I looked. All right. So when a method calls itself, that's recursion. So say I do this. Here's the simplest one, and it's stupid. It's not correctly implemented. Public static void R, right? And that's all. And as soon as you get into it, it calls itself. Maybe we can make it print a message, right? Show that we're calling itself. So R was entered. And so down in main, we could call R. And there we go, right? What's it going to do? It's just going to jump into the R method and continually call itself. Is that what it should do? Is that a well-written function? No, it's in pretty much the same idea as an infinite loop, except it's going to crash after a certain point. You can only call a function. A function can only call itself so many times because each time it enters a function, it has to allocate a little bit of extra memory. It's called using the stack. It has to allocate more memory on the stack. And then when that function exits, it releases that memory. But this one never exits, right? It keeps calling itself, keeps allocating a little bit more memory on the stack until it runs out. So, not a good thing. Instead, there needs to be some way of getting out of it. And what if we do something like this? We're going to pass in a number, right? So up here, we're going to pass in a number. And then what are we going to do? We're going to say if x is equal to 0, return, right? That's going to be our stopping point. Otherwise, what are we going to do? We're going to system.out.println x, and then we're going to call ourselves again after having subtracted 1 from x, right? So return x minus 1, right? So when we come in here, return R, parentheses, x minus 1. What are you complaining about? It's not supposed to return because it's void, right? Okay, so there we go. So this is what's called, maybe I should open up the PowerPoint. I can point at things in the PowerPoint. But if we get in here and we've hit our end case, then we're going to start bailing out, right? And then we get up here, we print out, and then we call ourselves again, and x has been reduced by 1. So it's going to print out 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Right? So what could we do that was interesting with that? Well, let's make it return an int. And then we're going to return x plus the return of x minus 1. Right? So when we get in here, what's it going to return? It's going to return 10 plus, what is this going to return? Eventually it's going to return 9, right? but it's also going to return 8, 7, 6, 5, 4, 3, 2, and 1. Now, I'm not real sure how to add print statements to that to make it look perfectly clear. Maybe I could do this. System.out.println parentheses entry, right? And then here we're going to do a system.out.println return 0, because that's our special case, right? And here, if we get this far, we're going to return x plus r x minus 1. X equals end quote plus x. Hope that makes sense, right? So this is going to show every time we come in here. Heck, we could say return entry x equals, right? And we'll see what x was when it first came in. And then if we happen to hit our ending point, we return 0. Otherwise, we're going to call ourselves, right? And so we're going to return 10 plus the result of calling ourselves with that function. Excuse me, with that argument. Maybe this output will make it a little bit clearer what it's doing. This is definitely why you should read the PowerPoint. So when we come in, the first time we call, we enter it with 10. And then we call the method again, passing in 9. So x was 10, but then when we are inside the method the second time, it's 9. And so then it's supposed to return 9 plus returning it by calling 8. And so we get here and it's supposed to return 8 plus the return value if you pass in 7 and so forth. And so it's going, this is a summation. That's the simplest way to demonstrate it, right, is a summation. I hope that makes sense. So recursion has two different cases. It has the recursive case. The recursive case is when it calls itself. And then it has, I believe it's called the null case. The null case is when it's hit the end point and it just needs to return without calling itself. Let's make sure I'm using the correct terms. Recursion, recursive case. No internet. Oh well. Come back and undo that in a minute. So that is one example, and it's got too many print statements in it. Let's lower it so that we only go in with 3, right? So that it doesn't go too many times. And let's run it with a breakpoint. So by the time we're going to call it, we're going to break there. So debug it, debug the file, or debug the project. We're right there. We're going to step into that method. Now we're inside here, right? And x is equal to 3, because that's what we called it with. And so now we call the print function that I did not necessarily. Oh, for Pete's sake. I didn't mean to do a step into at that point. Let's try it again. So debugged, get to here, step into, right, now we're in our method. Don't step into that one, it's just a print statement, right? So is x equals 0? No, it's still 3. So it skips that case. And now we're going to call ourselves reducing x by 1. So the next time we pop in, the second layer deep, we are now 9. I sure do hope that makes sense. One more thing I'm going to try to do to make the output look a little bit more clear. System.out.print, just print a space. But we're going to put a loop in here so that the number of spaces we print is equal to I'm not going to even go any farther with that, but I'm going to give another example. What if we wanted to print out a string in the worst fashion possible? What do I mean by that? printing out a string with a recursive function is just kind of absolutely silly. But we could do that, right? So public static void print str, and we're going to take a string. And so what do we need to do? We need to pick a starting position. And that's going to be I, the starting position. But we're going to give it a default value of 0. Why is that an error? Not allowed to do that? We're not allowed to give default values? All right, fine. Must be mistaking us with another programming language. Alrighty, so if I is equal to the length of the string, then we're done, the null case, right? Else, we're going to print the character at that position, string.char at I, right? And then we're going to call ourselves again, passing in the string and I plus 1. So we're starting off with I equals 0, or we will when we get down here, right? When we call print str and we pass in hello and we pass in a starting value of 0, right? So we want it to increase by 1 each time, and up to the point where the length has been exceeded, where we've hit past the last of the string. So then call ourselves again, right? Print str, the same string, but I plus 1. All right? This is the recursive case. So we have kind of the optional case, the null case that ends everything because it does not return. Excuse me, it does not recurse. It stops recursing. It starts zipping back into it. And here is, we do the body of our work, and then we call ourselves again modifying the parameters somehow. And eventually the parameter gets modified enough so that it knows to start exiting. I'll let you go away. All right. And see it printed out HELLO. Maybe I should have done a print line, right, just to make it a little bit easier to see rather than print. Okay. And there we go. A little too much printing now, right? But anyways, hope you see what's going on. We're calling ourselves, when you write a recursive function, there has to be two cases. There has to be the case where we do call ourselves recursively, modifying the input in some fashion, modifying the arguments in some fashion, and then we need the null case where we just start to bail out once we have finished the task. See if I can come up with one more example, and then we'll be done with this. I'm going to call this one R2, and it's just going to go up to 10. Right, we're going to start at 0 and go up to 10. But I'm going to have it print some spaces in order to indicate where we are, right? So a for loop starts at 0, keeps going while, I is less than x, I plus plus, system.out.println, print a tab or print a, yeah, why not a tab? And then let's print that it should have been public static void, right? And then let's print that we just entered. So system.out.print entered with x equals end quote plus x, right? Let's check to see if we've hit our endpoint. So if x is equal to, and let's just stop it at 4. If x is equal to 4, then we're going to return. But let's print a message out to that effect. System.out.println returning null case, right? I'm going to make that print, just on a hunch that it's going to look nice. And I'm going to make this print. But this is on our way of bailing out. So I'm going to make that print ln, and then we're going to call ourselves, right? And so down here, after we've ruled out the null case, we're going to have our recursive case. And so this is going to be returning the recursive case. And then we're going to call ourselves after having modified the data, right? So R2 x plus 1. So we're going to pass in 0, and then it's going to go up to 1, 2, and 3, and and stop because stop when it hits 4. We're going to need to remove that breakpoint, right? So pass in 0, and it's going to print 1, 2, 3, 4. And I hope this output looks the way that I want it. We'll see if it does or not. It may look totally lame, right? So it entered with x is equal to 0, and then it called itself with the recursive case. So now that we've called ourselves, we are this is one level deep of recursion. Now we are 2 levels deep in the recursion. So x is equal to 1, returning the recursive case, right? Now we're 3 levels deep. So x is equal to 2, we're returning the recursive case. Now we're 4 levels deep. X is equal to 3, returning the case. Now we're 5 levels deep. We are entering with 4, and we're returning the null case, right? So that's it. And then it zips all the way back out, right? Hope that makes sense. I really think that that's about enough of recursion that you really need to know. It is certainly a much larger topic than what is listed here. And some of the more advanced some of the more advanced sorting algorithms rely on recursion to do their job. Anything you can do with recursion, I'm not going to say anything. Anything you can do with looping, you might be able to do with recursion, but the coding of it's going to seem a little bit more alien to you unless you really, understand what you're doing. For example, printing out the string here, right? We could have just had a for loop that would print out each letter of the string. Instead, we wrote it as recursion, and so our brains, got boggled a little bit by doing that. There is a programming paradigm called functional programming, where your goal is to not have any state information, meaning you do not have temporary variables. And in some case like that, then you wind up writing a whole bunch of recursive algorithms. Not going to make an assignment based on recursion. I hope you understood this. Please, please, please read the chapter. At least read the PowerPoints. Get an idea of what the PowerPoints are talking about. I don't think I'm going to create a quiz for this, though. Usually skip quizzing on this. If you have the idea, it's calling itself, and then there are 2 cases. The 2 cases are when it needs to just start bailing out completely. That's the null case. Or we call ourselves again with modified data. That's the recursive case. 2 cases. Of course, there's more than maybe there's different ways you want to call it down here, right? You might have more than one recursive case. You might have some if statement that calls it one way or the other. But it's very important that you have a non-recursive case, and then you have a recursive case, at least one. All right. Hope that makes sense.